Hi everyone, I thought I would do one more video that talks about how we factor. This one's a little bit unique. So here we're looking at a function, let's say it's f of x is equal to x cubed minus 8. Here we can go ahead and we notice that again, the degree of the function is 3. So that means that I'm looking for 3 zeros. So the function will have 3 zeros that are either real or complex. Interestingly, Descartes' rule of signs for this problem is a little bit difficult to use, so I'm going to skip that part. Let's take a look at my possible factors for this, though. So I'm going to skip straight to step 3. So here, again, if I look at my possible values for p, I'm looking at this a-aught value, which is 8. So I'm looking at all the factors of 8. So I look at plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. If I look at my q values, I'm looking at the coefficient in front of my largest term, so my a sub n, which is going to be here, there's kind of an implied 1 right there. So I just have plus or minus 1. So here a sub a-aught was equal to 8, and an was equal, actually technically is equal to negative 8, and a sub n is equal to 1. So my possible factors for reals are going to be 1 divided by 1, which is just plus or minus 1, plus or minus 2 divided by 1, which is plus or minus 2, plus or minus 4 divided by 1, so plus or minus 4. You notice all of these are whole numbers, plus or minus 8 divided by 1. So these are all my possible roots. I am going to go ahead and take a look at each of the f of x's, and I'm going to start with positive values since I didn't use my Descartes rule. So here I'm going to look at f of 1 and see if it equals 0. If it equals 0, then I know that 1 is a 0 for this function. So if I do that, I have 1 cubed minus 8, which is just 1 minus 8, which equals negative 7. So here, that means that 1 is not a 0, because the function didn't equal 0 when I substituted in 1. So let's look next at f of 2. Here I get 2 cubed minus 8, which is equal to 8 minus 8, which equals 0. So from this, I say 2 is a 0, because f of x equals 0. We could also say 2 is a root, okay, of f of x. So now I know 2 is a root, but I want to find the coefficients for the other ones if I were to factor the x minus 2. This means I know that one of my factors is going to be x minus 2. And then it's times something else, and I want to find out what that other thing is, okay? I want to find out what this is. So the next thing I'm going to do is I'm going to do long division. So remember, I have f of x equals x cubed. I'm going to add on plus 0x squared plus 0x minus 8. So if I do my long division now, using my 2, I'm dividing in by 2. I have coefficients of 1, 0, 0, and negative 8. So if I bring down my 1, 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. And that means my remainder is 0, which is exactly what we would expect, right? Remember that this value matches this value when we do this. So if I were to do my division with 1, I would have a remainder of negative 7. This allows me to write my coefficients for when I factor out the 2, or the x minus 2 term, like this. So what I have is 1x squared plus 2x plus 4. Now if you look at this particular quadratic, we can't factor it So what we're going to use is the quadratic formula. We have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1. So if I continue to look at this, I have negative 2 plus or minus the square root of 4 minus 16 all over 2, which is equal to negative 2 plus or minus the square root of negative 12 over 2. So if I split this fraction up a little bit, I have negative 2 over 2 plus or minus square root of 12 is the square root of negative 1 over 2, which is going to be equal to negative 1 plus or minus, I can write this as the square root of 4 times 3, so I'm going to be able to take out the square root of 4 part, over 2 times I, which is going to equal to the square root of 3 over 2. Sorry, wait, let's put the beginning one in there, which is going to equal negative 1 plus or minus 2 the square root of 3 over 2 times I, which will just be equal negative 1 plus or minus the square root of 3i. So if we look here, our roots, or our zeros, are going to be at x is equal to 2, at x equals negative 1 plus the square root of 3i, and at x equals negative 1 minus the square root of 3i. Okay, so those are our zeros. If I want to write this, my f of x, in a fully factored form, what I have is f of x equals x minus 2 times x minus, I'm going to use this one, negative 1 plus the square root of 3i times x minus negative 1 minus the square root of 3i. And this is my fully factored form. So if you're looking at, let's say, problems 1 or 2 on the study guide, this is similar to those. Let me know if you have any questions. Thanks. Bye.